Hello everyone. In this video, we will see probability distribution. So there are different types of probability distribution: binomial distribution, Poisson distribution, uniform distribution, exponential distribution, gamma distribution, normal distribution, and chi-square distribution. Out of this, in this video, we will see probability of binomial distribution. In probability theory and statistics, binomial distribution is the discrete probability distribution that gives only two possible results in an experiment, either success or failure. For example, if you toss a coin, there could be only two possible outcomes, heads or tails. And another example, if test is taken, there could be only two results, pass or fail. This distribution is also called as binomial probability distribution. So to calculate probability of binomial distribution, let us consider we have to calculate probability of R success. So P of R is equal to NCR small p raised to R into small q raised to n minus R, where n is the number of repeated trials, p is the probability of success, q is the probability of failure. Here, in binomial distribution, there are only two possibilities, success or failure. So addition of these two probabilities, it is equal to 1. Also, we can calculate probability of failure is equal to 1 minus probability of success. So here, this NCR we can calculate by using this formula, n factorial upon r factorial into n minus r factorial. In this, NC0 is equal to 1, NC1 is equal to n, and NCN is equal to 1. In case of probability of binomial distribution, mean is equal to n into p. N is the number of repeated trials and small p is the probability of success. Then we can calculate variance, which is equal to npq. N is the number of repeated trial, p is the probability of success, and q is the probability of failure. And we can calculate standard deviation sigma, which is square root of variance, is equal to under root npq. Let us solve one problem based on binomial distribution. So problem is like this. On an average, a box containing 10 articles is likely to have 2 defectives. If we consider a consignment of 100 boxes, how many of them are expected to have 3 or less defective? And it is given that small p is equal to probability of box containing defective articles is equal to 2 by 10, which is equal to 1 by 5. And small q is equal to probability of non-defective items, which is equal to 8 divided by 10 is equal to 4 by 5. Here we have to calculate probability. If we consider consignment contain 100 boxes, how many of them are expected to have 3 or less defective? So here it is given that number of articles in box small n is equal to 10. Then probability of defective articles small q is equal to 1 by 5. And probability of non-defective items small q is equal to 4 by 5. If suppose probability of non-defective articles is not given, then we can calculate by using formula q is equal to 1 minus p. And here we have to calculate probability of box containing 3 or less defective articles, that is p of r less than 3. So less than 3 means it can be is equal to 3, it can be is equal to 2, it can be is equal to 1, or it can be is equal to 0. Means these are the possibilities of less than 3. So here we can add these probabilities. Here we can use the probability of binomial distribution p of r is equal to ncr into small p raised to r into small q raised to n minus r. So here we can calculate probability of 0 defect, that is r is equal to 0. So here r is equal to 0. So we can calculate p of r is equal to 0 by using this formula. So n is equal to 10. This ncr, r is 0. So 10c 0. then p it is 1 by 5, so 1 by 5 raised to r means raised to 0 into q raised to n minus r, n means 10 and r is 0. So 4 by 5 raised to 10 minus 0. So if we calculate this, then we will get 0.1074. Similarly, if we put r is equal to 1, then we will get 10c1 into 1 by 5 raised to 1 into 4 by 5 raised to 10 minus 1. And if we calculate this, then we will get 0.2684. Then for r is equal to 2, we will get 10c2 into 1 by 5 raised to 2 into 4 by 5 raised to 10 minus 2, which is equal to 0.302. Then if we put r is equal to 3, then we can write 10c3 into 4 by 5 raised to 10 minus 3, which is equal to 0.2013. Then here to calculate probability of r less than 3, that is probability of defective article less than 3 is addition of these 4 probabilities. So if we add these 4, then we will get probability of r less than 3 is equal to 0.8791. So this is for one box. Here if we consider a consignment of 100 boxes, so here for 100 boxes we have to multiply by 100 to this, so we will get 87.91. so out of 100 boxes, 87.91 box means 88 boxes. So we can say 88 boxes are expected to contain 3 or less defective articles. So in this way we can use formula for probability of binomial distribution to solve the problem. Thank you.